Piecewise functions are kind of like your regular function, except for they have two or more expressions, and they're defined by some interval. So you can see here we have x squared plus 2 when x is greater than 1, and then negative x minus 1 when x is less than or equal to 1. So depending what your x value is, you look at this as like your rule, and then these two expressions tell you what to plug in. So always look here first for the rule and then plug into whatever expression your x value falls under. So for this one, f of 1, 1 is less than or equal to 1. So we would plug into this expression. So to do that, we would do it just like how we did it before, where you put parentheses anywhere you see an x. So negative parenthesis minus 1, and then I'm going to plug in 1. So negative 1 minus 1, our answer is negative 2. So that's the answer to f of 1. It equals negative 2. For this one, f of 2, for f of 2, 2 is greater than 1. So keep in mind, this is the greater than symbol. This is the less than symbol because it kind of looks like an L. That's how I like to remember it. So since 2 is greater than 1, we're going to use this expression now. So same thing, parenthesis, wherever we see an X. And then we're going to fill in this parenthesis with 2 because that's what we have. So when we do 2 squared, we get 4 plus 2, which equals 6. And so f of 2 would equal 6. We can do the same thing for f of 3. So 3 is also greater than 1, so it goes under this expression. So parenthesis plus 2. We fill in the parenthesis with 3 because that's what we have here. 3 squared is 9 plus 2. So f of 3 is 11. So we're also going to look at what the domain of functions are, and it's how far left and right a graph goes. So it goes with our x values or input values. These are the 3 rules that we use for domain. We're not really going to be looking at this third rule because we haven't worked with logs all that much, or if at all. We're going to be looking at logs later in the school year. So to start off, we'll just be focusing on these 2 rules. So they're basically just the normal rules of math. We don't want negatives under a square root. So that means we're going to have everything under the square root be positive. And positive numbers are numbers that are greater than or equal to 0. So whatever is under this, we want to be greater than or equal to 0 because those are positive numbers, because we want no negatives. For number 2, we never want a 0 in the denominator. So once again, just another rule in math. So whatever's in the denominator cannot equal 0 if we have a fraction. So those are the 2 times that we're going to really be working with where the domain won't be what we call all real numbers, or you can use any value for x. This page just gives you some rules when writing domain or range using interval notation. So you always use these little squiggly brackets whenever you do domain. If you're working on domain, you would put a little d for domain and a colon, and then your squiggly brackets. If it's range, you would put an r. You can use positive and negative infinity if it goes on forever in the positive or negative direction. So for domain, positive infinity would be going to the right and negative would be going to the left. All real numbers is what I was talking about before. So this is the symbol. It's an R with a little line through it. It means there's no domain restriction. So if you don't have a square root and you don't have a fraction, your domain is always all real numbers. And then here's the less than symbol. We always use the less than symbols when doing domain. And we also have the less than or equal to with the little equal bar under it. That's when we're including the number in this domain or range. We always use just regular less than, not equal to for infinity because we can't be equal to infinity. So for these examples, the first one is a set of coordinate points. The domain always goes with x, our inputs. So for this domain, we can actually just list out all the different x values. So we have -1, -3, 5, and 6. And then we're done. And notice how I use the squiggly brackets. I know they don't look very pretty, but that's all you would have to do. For B, so now we're looking at this algebraically. We want to check, does it have a square root? So not a square, this is a square as an exponent, but a square root. This does not have a square root. It also does not have a fraction. So because of those two things, it doesn't have a square root and it doesn't have a fraction. Our domain is all real numbers, and we can write it like this. So once again, you have the D, the colon, and then the squiggly brackets with the R with the line through it. It means you can plug in any number for X. There's no restrictions on it. You can use any number and it'll work in this expression. So for C, if you look at this algebraic equation, we do have a fraction. So what we want to do is make sure that this denominator is not equal to 0. So we can kind of think about that logically. Or we can actually put x plus 5 cannot equal 0 and solve this like a regular equation. So if we subtract 5 from both sides, x cannot equal -5. So that is our domain. Domain with the little squiggly brackets, and you're done. You can also think of it, okay, -5 plus 5 gives me 0. That would make my denominator 0. But sometimes it's a little bit tricky, so you have to actually do it out. For these examples, we have square roots. So here, if we have a square root, we want what's under it to be positive or greater than or equal to 0. So that's what we're going to do. 2x plus 1 has to be greater than or equal to 0 because this must be positive, because we can't have a negative under a square root. That'll give us an imaginary number. So we're going to subtract 1 from both sides, and then we're going to divide by 2. So x has to be greater than or equal to -1/2, and that would be my domain. So if you plug in any x value that's greater than or equal to -1/2, you will not get a negative under your square root. And that's my final answer. So we can do the same thing for this one. Now what's tricky about this one is we're going to have to factor. Anytime you have an x squared, you have to factor. In this case, we're going to pull out a GCF, and that greatest common factor is x. So whenever we factor, after we pull out a GCF or due to binomials, we want to set each of these equal to, and in this case, greater than or equal to 0. So our domain is x has to be greater than or equal to 0, and x plus 2 has to be greater than or equal to 0, which would mean x has to be greater than or equal to -2. So both of these would be our domain. So if we think about this, this one is saying we have to be greater than or equal to -2. And this one is saying we have to be greater than or equal to 0. So we want to pick the bigger number. And our domain would just be x is greater than or equal to 0, because if this is a condition, technically this is -2 is too far down, because this is saying x has to be greater than or equal to 0, and -2 is not greater than or equal to 0. When we're looking at it on a graph, we're going to look at the x values. So the furthest x value we have is right here. This is 8. So this is where we're going to set up our brackets with x in the middle and put the less than signs around x. And on the right side, we go to 8. On the left side, there's an arrow saying we go to the left forever. So that's where we would use this negative infinity. Here we have arrows on both ends. So this is saying that we're going from negative infinity to infinity, which you can also write as all real numbers.